Hi, chemistry students. I wanted to touch base with you as we finish up this unit on acids about something called titrations. So titrations take advantage of the neutralization reaction, which is a reaction between an acid and a base that creates salt and water. And they use that neutralization reaction to determine what the concentration is of some unknown either acid or base. And so we would do them in the lab if we were at school. So I want to show you a short video that kind of shows you how that works. And then we'll talk about the math and the calculations that go with that. So I think you can see this. The way this works is this is a pipette. We've worked with pipettes in the past, so you know what that looks like. Or burette, excuse me. I used the wrong word. A burette. And so it's a very particular amount of volume that it delivers. So the person is tapping on it right now to get air bubbles out. You're very careful that you put your unknown in. You know exactly how much you start at. And for a titration, you then record where you started and where you end, because what you want to know is how much volume of the unknown does it take for you to neutralize it. So we use an indicator, and that indicator then, whenever that indicator shows us that we've reached the neutralization point, a pH of 7, then we can do calculations to figure out what must the concentration have been of the unknown in order to make that happen. So here they've put a set amount that they knew, and they put some indicator. That was the second drops that he put in. And so now what he's doing is stirring it and just slowly adding a bit more of the base, which is what he has in the burette. And as he adds it, he's getting it to a place where you can see it kind of turns pink and then it goes away, and he's getting it just to the point that it barely turns pink. Oh, it turned pink. So now he's going to put a little bit more acid in there, and he's going to figure out how much did it take for it to just get to that point that it's pink. And then he's going to be able to do some calculations with that, which is what we want to talk about here. So we're going to go ahead and stop watching this and switch back to our PowerPoint and learn and look at how do we do those calculations. So this is not going to be anything new in terms of content. It's all stuff that you already knew, but we're going to do it and kind of put them together in a different way. So let's look at this situation. A titration reveals that there's 11.6 milliliters of a 3 molar sulfuric acid required to neutralize sodium hydroxide and 25 milliliters of a sodium hydroxide solution. So first thing, we need to go back and practice your naming of acids and make sure that you know the name of, or the formula for sulfuric acid. So go ahead and go back to your notes if you need to. What is the formula for sulfuric, there's no hydro, sulfuric acid? Hopefully you said H2SO4, because that would be absolutely correct if you said H2SO4. Oops, I didn't mean to go forward. I'm trying to write on the slide. So let's go ahead and see if I can make this work. There we go. H2SO4 is sulfuric acid, and sodium hydroxide, we're just going to name the exact same way we always have, sodium, and then the polyatomic ion hydroxide is NaOH, as it already gives it to you in the problem. So if this is a neutralization reaction, we know it's going to make a salt and water. So we can go ahead and put water in. That's obviously going to happen. What's going to happen is we're going to have the H be given up by the SO4, and this anion that's left behind will combine with the cation Na, and we're going to make Na2SO4. So that's not balanced because we have to have two NAs over here, so we're going to have two NaOHs, which is good because that two OHs will go with the two H's and give us two waters. So now it's a balanced reaction. So now we want to look at what do we know. Well, we know that we are going to start out with, let's see if I can, get my pen back on here. We are going to start out with, it says that we have 11.6 milliliters of H2SO4, and it's a 3 molar solution. We know that we have 25 milliliters of NaOH, but we don't know what its molarity is. That's what we want to know. So the first thing we need to do is we need to step back into last chapter and remember what is the formula for molarity. Well, molarity is equal to moles per liter of whatever substance we're talking about. And so we need to figure out the moles per liter. Now we have milliliters. We can easily change milliliters to liters. So we'll just move it over 3 spots. So it'll be 0.0116 and 0.025. Those would be liters then. And we can then figure out moles, and we know stoichiometry. So let's start over here. Over here, we have enough information to figure out how many moles of the acid we have. So we're going to do 3 is equal to moles of the acid divided by 0.0116. So to get the moles of the acid, we need to get the 0.0116 to the other side. It's being divided right now. The opposite of division is multiplication. So 0.0116 times 3 tells us that we have 0.0348 moles of acid. Now we know the number of moles. When we know the moles of one thing, can we figure out the moles of another thing? Absolutely, that's called stoichiometry, and you guys are pros at that. So we start by putting what we're given over 1, 0.0348 moles of acid over 1. We want the acid on the bottom. We're trying to find out how many moles of the base. So the acid in this case, we have to look at the coefficient when we're going from moles from one to the other. The acid has a 1 in front of it. The base has a 2 in front of it. And so we have that there, and the acid will cancel out. Oops, not times, we're going to equals, and we're going to end up with moles of base, which is NaOH in this situation. So simply multiply by 2, and we get 0.0696. Now we have the moles of the base. So we need to know the molarity. Well, we know that molarity is equal to the moles of the base divided by the volume of the base. And we now know that this is equal to 0.0696. So all we have to do is divide that by 0.025, and we find out the molarity of our base is 2.8 if we do sig figs. It's a 2.8 molar sodium hydroxide solution. So let's review that real quick. First thing we did was write a balanced equation. It's always a good place to start. The second thing we did was remind ourselves of the molarity formula. We used that molarity formula, number 3, to figure out the moles of the acid. Then number 4, we were able to do a stoichiometry problem. That stoichiometry problem led us to be able to figure out the moles of the base, which we could then use number 5 to figure out the molarity of the base. So as you can see, none of this is stuff that you haven't done before. It's just that you've never put it together quite this way. So take a minute, pause the video, make sure that you understand how we did this, write down any questions, email them to me or come to office hours so that we can figure it out together. I want to show you one more thing before we head out for today. And that is that there's a shortcut. So now that you just took a few moments to understand that, there actually is a shortcut. I wanted you to understand exactly why the shortcut works, which is why we did the long way first. But there is a shortcut. Because what in essence we're doing is we want to make sure that the number of H's that we have matches the number of OH's so that they balance each other out so that our concentration is equal for both of them, which we talked about pH earlier. That's what pH is when the H and the OH concentrations are equal. So really, if we look back to the formula for molarity, molarity is the moles divided by the volume, the liters, right? And so if you look at this, if we switch this around, this is the same formula, right? Algebraically, that's the same thing. And when we're talking about an acid, the moles that we're talking about the acid having is the moles of hydrogen ions or the moles of hydroxide ions if it's a base. And so we really want those concentrations to be the same. So if the number of moles are the same, then we're going to have a neutralization reaction. And so we can just set those equally to each other. The only time that we have a problem with that is like the example that we just did with sulfuric acid. If we have a polyprotic, what do you hear in the word poly? Like polygon, polygamy, I guess. Not a great example of it, but poly means more than one. And so you can see there that we have more than one. If we have more than one acid, it's going to give more than one hydrogen. That's going to mess things up. So we do have to have the number that each of these provides listed in the front. So we just added that. In most cases, that number is going to be 1 if it's just one hydroxide and one hydrogen that's offered. So let's go ahead and try one more problem and see if this makes it a little bit easier. So let's look at what it gives us. We're going to try to use this formula. The number of hydrogens given by the molarity of the acid times the volume of the acid equals the number given by the base times the molarity of the base times the volume of the base. The volumes, let me note for a second here, because of the way this formula is set up, as long as they match, it doesn't matter what they are. So they might be both liters, they might both be milliliters, it doesn't matter. You don't need to convert it. You just need to make sure that they're the same as each other. So let's go ahead and see what we've got here. You go ahead and try it, and then I'll work it and see if we can match it up. Okay, now that you've tried it, let's see what you got. So first we want to notice this is the information that goes for the base, so we're going to put this on the base side. There's only one OH here, so we don't have to worry about that number. We could put a 1 in if we want. That makes it easier in your mind. The molarity is 1.008. The volume, we can just leave it in milliliters. On the other side, what we know is we just know the volume, so we can put that here. And it says it's a monoprotic, so we know it's going to be a 1. We don't know the molarity of the acid. That's what we want to know. So first thing we want to do is multiply on the right-hand side. 1.008 times 26.23. So over here we get 26.439. And on the other side, obviously the 1 we can just forget about. We want to divide that. So we had the molarity of the acid times 150.2. We need to get rid of that 150.2, get it to the other side. And we end up with the molarity of the base equals, looks like we need to have 4 significant figures, 0.1760 molar. So it's quite dilute. That means there's been put a lot of water with it. So there's not a whole lot of actual acid, per volume that we have. So see how it's the same process. You could have done this problem exactly the same way we did the other one, but that does make it a little simpler. That is it for acids and bases. Feel free to let me know if you have any questions. Stop in at office hours, and I will see you later.